All right, so we're going to start with Unit 1 for the review. We're starting with distance and midpoint. So the distance formula is going to be d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's all under the square root. So remember, x2 and x1 and y2 and y1, those come from points. So if I have an x1, y1 as a 1 point, and x2, y2 as another point, I'm finding the distance between this point and this point. And then midpoint, so midpoint is the middle point in the middle of a line. So again, I'm going to use x1, y1, x2, and y2. So x1 plus x2 divide by 2, and then y1 plus y2 divide by 2. Okay, and so we'll use these two on a couple of the next problems. But first, we're going to do a fractional distance problem. So it says the point B lies between point K and L. The distance between point K and B, so B is going to be the point that's somewhere between K and L, is 1/6 of KL. So 1/6 of the total distance between K and L. So what is the coordinate of point B? So the very first thing I want to do is I want to first find the distance between K and L. So I want to find the distance from K to L. So K is at -9. Be careful. We can't just add them together. I need to find what the distance is because we can't have negative distance. I'm gonna look and see what I have between -9 to 0. So from -9 to 0 is a distance of +9. And I'm going to do 0 to 15. And that's +15. So my total distance is 9 plus 15. And that equals 24. And then I want to find what 1/6 of that total distance is going to be. So 24, my total distance, right? That's the distance between K and L, times 1/6, which is just like doing 24 divided by 6, and that equals 4. Now be careful, this is the distance. This is not the actual location of the point. Okay, so I know that the distance from K to B should be 4. So I know K is at -9. So to find B, I'm just going to take -9, and I'm going to add my distance of 4, which gives me the point location of -5. So point B is located at -5. All right, so next problem, I am dealing with a midpoint. So remember, midpoint is the point in the middle. So I want to find the midpoint between A and C. So there's two ways you can do this. Because I have a picture, I could just count on the number line, or I could also use the numbers to find the total distance, okay? So I'm going to go ahead and just count on the number line. So from -7 to -1, it's going to be 1, 2, 3, 4, 5, 6. Okay, so that's a total distance of 6. So if my total distance is 6 and I want to find the midpoint, I'm going to divide by 2. I'm going to cut it in half. So 6 divided by 2, that equals 3. And again, that equals the distance, not my actual location of my point. So the distance from my first point to my midpoint is 3. So from -7 plus 3, a distance of 3, gives me a location of -4. So my midpoint is at negative 4. Okay? So, next it wants me to find the midpoint on a 2-dimensional. So I have an x dimension and I have a y dimension. So that's where my formula from up here is going to come into play. So what I'm going to do is I'm going to go ahead and call this point A and this point B. So I know that A is at 1, 2, 3, 4, negative 4, negative 1, because I went 1 down. And B is at, there's 4, so 5, and then 1, 2, 3. So B is at 5, 3. Okay, so now I'm just going to plug it into my midpoint formula. So midpoint equals, I'm going to make this x1, y1, x2, y2. So negative 4 plus 5 divided by 2. And then this is a comma because we're going to end up with a point. Okay, and then y1 is negative 1 plus y2 is 3 and divide by 2. Okay, so I get negative 4 plus 5 is positive 1 divided by 2. And then I get negative 1 plus 3, and that is 2 divided by 2. So I get positive 1/2, and 2 divided by 2 is just 1. So my midpoint is going to be 1/2, 1. So here is 1/2, my x, and then I go up 1 right there. And you can kind of see that is the very middle of my line. Okay? So when you're on the test, you can always double check if you have a picture by plotting it, because if I ended up with a midpoint somewhere over here, obviously that's not correct, right? So if it's not on your line, it's incorrect. And if it doesn't look, if I had one like way over here, that would be incorrect, right? Because that's not the middle of my line. All right, so that was my midpoint. Now we're going to do another distance problem, but there's going to be 2 ways we could do this problem, and I'm going to show you both. So first, it says that we have the vertices, the vertices of ABC are A is at 0, 1, B is at 4, 1, and C is at 0, 4. What is the length of the hypotenuse of the triangle formed by these points? So over here on my graph, I have my points for my triangle. So I'm going to go ahead, I'm going to outline these so y'all can see my triangle. Okay, so here's my triangle. Now, we know that this is a right triangle, right? This is a right triangle. So I have a hypotenuse. Remember, the hypotenuse is the longest side of the right triangle, and it's across from my right angle. So here, from here to here, that is my hypotenuse. So from C, B, that is my hypotenuse, okay? So that is what I'm trying to find the distance of. So since it's a right triangle, not only can we use distance formula, but we can also use Pythagorean theorem. So remember when it says length, that's when you're going to use distance formula. If it says distance, that's when you can use distance formula. But because I have a graph and I can see that this is a right triangle, I can go ahead and use Pythagorean theorem. So I'm going to do that one first. So I can go ahead here. If it's lined up with my graph, then I can just count the sides. So for this side, I have 1, 2, 3. So from C to A is 3. And from A to B is 1, 2, 3, 4. Okay, so remember Pythagorean theorem is A squared plus B squared equals C squared. And it doesn't matter where 3 and 4 go. They can be A or they can be B. It doesn't matter. As long as we know that CB has to be C, right? Because that's my hypotenuse. So your hypotenuse has to be C. So I have, let's do 3 squared plus 4 squared equals C squared. 3 squared is 9 plus 4 squared is 16, which equals C squared. Now 9 plus 16 is 25. that equals c squared. And then to get rid of my square, I'm going to do the opposite. So I'm going to square root both sides. So the square root of 25 is 5 equals c, because my square and my square root cancel out. Okay, so I get that the hypotenuse is 5. Okay, now I can do the exact same thing with distance formula. So I'm going to demonstrate that for you. So I have distance formula is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going between B and C. So it doesn't matter which one I choose for the first point and which one I choose for the second point, as long as I'm consistent. So I'm going to go ahead and say that this is x1, y1, and this is x2 and y2. So here's the distance equals the square root. x2 is 0. Oops. Minus x1, which is 4, that's squared, plus y2, which is 4, minus y1, which is 1. And I just kind of scratch them out as I go so I don't get confused, and I know which ones I've used, okay? So here is D equals the square root. 0 minus 4 is just negative 4 squared, plus 4 minus 1 is 3 squared. Negative 4 squared is positive 16. Remember that any negative you square is going to end up positive. So we get 16. So the square root of 16 plus 3 squared is 9. So plus 9. 16 plus 9, that should look familiar, right? 9 plus 16 we had over here. So distance equals the square root of 25. So the distance is 5. So we get the same answers, right? So either way, if you're more comfortable with Pythagorean theorem, or if you're more comfortable using distance formula, it doesn't matter, as long as you do your squares and square roots correctly. Okay, so that one is distance. We did some midpoints. So now what we're going to talk about is parallel and perpendicular lines. That was the last thing we did for this unit. So we're going to first talk about our types of equations. Okay, so the first form we have is slope-intercept form. So slope-intercept form is the one y'all remember as y equals mx plus b. So y and x, those are going to just stay y and x. Those are your variables. And then m is going to be your slope. Okay, so we like to get equations into y equals mx plus b form because slope is very easy to find then. It's always right next to the x in slope-intercept form. So, and then this b is going to be your y-intercept. So where I cross the y-axis. Y-intercept. Okay. Now it says what is point slope form. So point slope form is also important for us. You'll see in just a second when we do our problems. So point slope means I'm going to be able to put in a point if I have a point. And then I'm also going to have the slope there. So my point slope form is going to be y minus y1 equals m times x minus x1. So where x1, y1 is a point, and then m is still my slope, and then just my plane y and my plane x, my plane x are still my variables, okay? So now I want standard form. So standard form, you're not going to be really using that much, but it might be nice to be able to recognize if you're given standard form on the test, what you need to do to move it to where you can work with your slopes. So standard form is a x plus b y plus c equals 0, where a, b, and c, those are all constants, so just numbers. But be careful, none of these are slope, okay? So I can't find slope just looking at an equation that looks like this. I will need to then make it into an equation that looks like either point slope or looks like slope-intercept form. Okay, so my first problem here, it says I want to find the equation of a line that passes through my point 1, 2, and is parallel to my equation of y equals x plus 3. So what does parallel mean? Parallel means we have the same slope. Okay, so I want something that has the same slope as this equation but runs through this point. So since I have a point and I'm going to find a slope, I'm going to use point slope form. So first thing, my equation right here is already in y equals mx plus b form, my slope-intercept form. So my slope is real easy to find. It's just the number that's in front of x. You might notice there's no number in front of x, but when we just have ax, it's going to be 1. So my slope is equal to 1. So since it's parallel, we're going to keep this slope. So I'm going to go ahead and put it into my my point slope form. So y minus y1 equals m times x minus x1. So y minus y1 is 2 equals, and then my slope is 1 times x minus x1, which is 1. Okay, now I'm just going to distribute, and I'm going to go ahead and move everything over so that way we get y equals mx plus b form. So I'm going to go ahead and add this 2, because this 1, anything times 1 is just itself, so when I distribute this 1, it's just going to get the same thing. So that'll be x minus 1. So I'm going to add an additional 2 to this side. That's y equals x minus 1 plus 2 gives me plus 1. So my final equation is y equals x plus 1. All right, so number 11, same thing except something very distinctly different. This time, we want an equation of a line that is perpendicular to the given equation. So here's my equation, here's my point, and this time I want perpendicular. So what do we do for perpendicular slopes? So instead of having the same slope, this time what you're going to do is you're going to take your slope and you're going to flip the numbers, and you're going to change the sign. Okay, so if it's positive, it's going to go to negative. If it's negative, it's going to go to positive. So if I have 1/2, so my original slope is 1/2. I'm going to change that to my perpendicular slope, which the symbol just means perpendicular. So I'm going to flip the numbers, and I'm going to change the sign. So I originally have a slope that's positive, so I'm going to change that to negative. So I have negative, and then I'm going to flip the number, so now I have 2/1, and 2/1 is just equal to 2. So my new slope is -2. Okay, so be careful too. Sometimes you might get confused if your slope is originally, say, 3. Well, 3 is just 3/1. So if I were to flip that, it's just going to become 1/3. Okay, so if you have a whole number and you're changing into a perpendicular slope, you're just going to put the whole number over 1, and then you're going to flip it. So it's going to be 1 whatever, in this case 1/3. Okay, so back to our problem. Again, I'm going to use my point slope form. So again, I'm going to go y minus my y1 is 2. And that equals my slope. So my new slope is -2 times x minus -3. So remember, when I have double negative, so I have a minus -3, it's going to become a positive. So I have x plus 3. So now I'm going to go ahead and distribute this -2 out. So I get y minus 2 equals -2x plus, we got positive 3 minus 2. So we're going to get a -6. Okay, so don't forget to distribute to the second part in my parentheses as well. And then I'm going to add this 2 to both sides. Get rid of it on that side. So I get y equals -2x. And then I have -6 plus 2. So that's going to give me -4. So my end equation is y equals -2x minus 4. Oh, okay. So last thing for Unit 1 is angle addition. Okay, so in this case, we have an angle addition problem that says bisect. Most of y'all should be familiar with the word bisect. So bisect, remember, that means we are going to cut in half. So whatever we're dealing with, we're going to cut in half. Okay, so in this case, we're dealing with angles. So that means I'm going to, cut my angle in half. So it says MO, my ray MO bisects my angle LMN. So make sure you're paying attention to what the angle says, because LMN is my big angle. So I'm cutting this whole big angle in half. So before I get to any other information, I'm just going to go ahead and mark what I know. So if I'm bisecting it, I'm cutting this big angle in half, I know I'm going to get 2 equal angles, right? So if I cut a segment in half, I'm going to get 2 equal parts. So the same thing with this angle. If I cut the big angle in half, that means that this segment is going to be equal to this segment, okay? So now the rest of the question is the measure of LMN. So LMN, so that is the whole angle. So I'm going to go ahead and write whole angle. Is 8x plus 2. And then LMO, so that's only this part right here, is 2x plus 7. Okay. So they don't give me this part. We want to find the measure of NMO. So NMO is this measure. So first thing we have to do is we have to solve for x, because I have these x variables, okay? So we just got to be careful, because usually what y'all want to do with bisect problems is set these two things equal to each other. But we don't have a value for this, okay? So I have to think, I have the whole angle, so how many of my little angles makes my big angle? Well, I know that 2 of these angles makes my big angle. So what I'm going to do is I'm going to take 8x plus 2 and set that equal to 2 of my small angles. So 2x plus 7 plus 2x plus 7. You could also multiply by 2. I'm just going to add a second one. So then I get 8x plus 2 equals, and I have 2x and 2x. So that gives me 4x. Plus 7 and plus 7, so plus 14. So remember, unless I'm moving it across the equal sign, I don't change the sign if I'm just combining on this side. When I move across the equal sign, that's when I change its sign. So if I have a positive 4 here, and I want to move it over here, now I'm going to subtract 4x minus 4x. So that gives me 4x plus 2 equals 14. I'm going to do the same thing to this 2, move that over. So I'm going to do minus 2 and then minus 2. So that's going to give me 4x equals 14 minus 2, which is 12. And then last thing I'm going to do is divide by 4 from both sides, get that x by itself. So x equals 12 divided by 4, which is 3. So x equals 3. But we're not done yet, because it said find the measure of angle NMO. So I don't have an equation for MNO, but I know that these two angles should be equal. So all I'm going to do is I'm going to plug x into this equation for this angle, because they should be the same. So 2 times 3, my x, plus 7. So 2 times 3 is 6, plus 7, so that gives me 13. Okay, so the measure of angle NMO is 13 degrees. Okay? All right, and that is the end of Unit 1.